This is Reigate College Maths, Year 2, Pure 6, and we're going to look at a differentiation topic, connected rates of change. So connected rates of change are connecting together two variables which change with respect to another one, and usually that's going to be over time. So for example, if we have the radius of a container changing, then its volume will also change over time, and the two are related together. Often it's going to be area, volume, temperature, those sort of things which change over time. So let's look at our first example here. The radius of a circle is increasing at a constant rate of 0.2 centimeters per second. Show that the perimeter of the circle is increasing at this given rate. So let's define our variables. Let's say P equals perimeter and R equals radius, and we're going to use T for time, which is completely standard. So what do we know about the perimeter of a circle? Well, we normally call it the circumference, don't we? So P is equal to 2 pi r. And then we're going to use the chain rule. So you can see the chain rule up here, but in this case we want to find the rate at which the perimeter of the circle is increasing. So we want to find dp over dt, dp by dt. And we're going to say that we know that the radius is increasing at this constant rate. Well, the rate of increase of radius is dr by dt. We're going to use the chain rule. I tend to write it out like this, dp, and down at the bottom here, dt. And then what other variable have we got? Well, we've got r, so dr there and dr there. Now, if we know what P is, we can find dP by dr. We just differentiate that, so dP by dr is 2 pi times dr by dt. Well, that's what we're given here, 0.2 centimeters per second, so times 0.2, which is 0.4 pi centimeters per second, which is what we've been asked to show. You could also write out dP by dr equals 2 pi and dr by dt equals 0.2, just to make it really clear. Let's go on to part B. Find the rate at which the area of the circle is increasing when the radius is 10 centimeters. So now we want the area. So we're going to say for B, A is area. We're going to have dA by dt is equal to dA by dr times dr by dt. And we know what the area of a circle is. Area is pi r squared. So dA by dt is equal to 2 pi r. So at where are we? Oh, sorry. Let's simplify it. So we're going to say dA by dt is equal to 2 pi r times dr by dt, and dr by dt was 0.2, so 0.2, so it's equal to 0.4 pi r at r equals 10, dA by dt is equal to 0.4 pi times 10 which is 4 pi centimeters squared per second. Then finally, find the radius of the circle when its area is increasing at the rate of 20 centimeters squared per second. Well, for C, we're now going to say dA by dt equals 20, but we've got an expression for dA by dt here, so we can just say 0.4 pi r is equal to 20. That means r is equal to 50 over pi, and if you work that out on your calculator, that's 15.9 centimeters. So when the area of the circle is increasing at a rate of 20 centimeters squared per second, the radius is 15.9 centimeters. I'm just going to do a second example because I think it's quite useful to see a volume one as well. So here we're going to say the volume of a sphere is increasing at the rate of 100 centimeters cubed per second, and we want to find the rate of increase of the radius of the sphere at the instant radius is 3 centimeters. So we're going to need the formula for the volume of a sphere, which is this: volume of sphere V is equal to 4/3 pi r cubed. Rate of increase of the radius of the sphere, so we want to find dr by dt. So what we're going to do is we are going to write out dr by dt is equal to dr by dv times dv by dt. Now, this is good because dv by dt is what we've been given here. So let's just write that down to make it nice and clear. dv by dt is equal to 100. What about dr by dv? Well, we've got v in terms of r, so we can find dv by dr. dv by dr is equal to, I'm going to bring that 3 down, so it's going to be 4 pi r squared. And that means that dr by dv, which is equal to 1 over dv by dr, so it's 1 over 4 pi r squared. So we've now got dr by dt is equal to, what do we have? This times this, so it's 1 over 4 pi r squared times 100, so it's 25 over pi r squared. And then we want to find the value at the instant when the radius is 3 centimeters. So when r equals 3, d r by dt is equal to 25 over pi times 3 squared, which is 25 over 9 pi centimeters per second. And we could work out that value itself, which I think in questions like this, an exact answer like that doesn't really make all that much sense. So let's work that out on our calculator. So we've got fraction 25 over 9 pi, which is 0.884. Sure if you can see that. Yeah, there we are. Which is 0.884 centimeters per second to 3 significant figures. You should be giving answers, unless you're told otherwise in the question, to 2 or 3 significant figures. So here we could say 0.88 to 2 significant figures. Okay, and that's it for the moment. That's connected rates of change.